Good day, everyone. This is the Mathematips of House of Samson in 11 Amos. In this video, we will talk about independent versus dependent event. First, addition rule of independent event. The formula of this rule is the P of A or B is equals to P of A plus P of B. This basically means that we are just going to add the two probabilities that we got in the certain problem. Second is the multiplication rule. This rule has a formula of P of A and B is equals to P of A times P of B. In the word and, we are just going to multiply the probability that we got in the certain problem.
Independent event, it influences the probability of other events, or their probability of occurring is affected by other events. So, a dependent event can only occur if another event occurs first. The primary focus when analyzing is its probability. Two events are said to be mutually exclusive if the occurrence of one event means that the other event cannot occur. In this case, when one event takes place, the probability of other event occurring is 0.
In this video, we will be talking about the independent events. Independent events refer to the occurrence of one event not affecting the probability of another event. You can use this formula where the probability of A and B is equal to the probability of event A times the probability of event B. Let's do an example. For example, let's say we are rolling a die and flipping a coin. Both of these are two separate events. We can say that the first event is rolling a die and the second event is flipping a coin. Because of the outcome of the first event does not affect the outcome of the second event, these events are said to be independent events. In other words, rolling a stick does not increase or decrease the probability of a coin landing on heads or tails. The probability of getting heads is 0.5 and it stays that the way regardless of what you roll, to calculate the probability of two independent events happening together. If you roll a 6-sided die and flip a coin, what is the probability of rolling a 5 and getting heads? We need to know the probabilities of each event. If you watched the previous video, you should know the probability of an event is equal to the total number of favorable outcomes divided by total number of possible outcomes. For the first event, there is only one favored outcome, which is rolling a 5, and there are total of 6 possible outcomes since we are rolling a 6-sided die. As a result, the probability of rolling a 5 is equal to 1 over 6. For the second event, we know that the probability of getting heads is equal to 1 over 2 or 50%, and because there is only one desired outcome, which is getting heads, and there are total of 2 possible outcomes since the coin land on either heads or tails. Now that we have the probabilities of each event, we can use the formula and all we have to do is multiply them together. 1 over 6 times 1 over 2. Give an answer of 1 over 12 result. The probability of rolling a 5 and getting heads is equal to 1 over 12 or 0.0833.
I'm gonna give you an example of dependent event. You know, events are dependent if the outcome of one event affects the outcome of another. For example, if you draw two colored balls from a bag and the first ball is not replaced before you draw the second ball, then the outcome of the second draw will be affected by the outcome of the first draw. I'm gonna give you another example. A jar contains one blue, one green, one pink, one purple, and one yellow ball. One ball is taken from the jar and is not replaced. If another ball is taken out of the jar, what is the probability that the first ball is blue and the second ball is green? Because the first ball is not replaced, the sample space of the second event B, is changed. Event A, blue sample space equals 5 balls. Event B, green, sample space equal 4 balls. P blue then green equals P blue times P green equals 1 over 5 times 1 over 4 equals 1 over 20. That's it. Thank you guys for watching our Mathematips video. Once again, we are the House of Samson.